Okay, thank you friends for being flexible with me this week. I have an exam on Monday that is only offered during a certain time that conflicts with tutoring, and instead of emailing the professor and trying to find a different time that he would open the Blackboard exam for me, I decided it might be easier to make a video for you guys instead, and so I can take the exam at the same time as the others and not have to be, not have to be a burden to my professor. So, I believe you guys should be talking about transcription translation, chapter 17. So hopefully you guys are. It'd really suck if I made this whole video and you guys weren't, but I'm pretty confident you are. So we replicated the DNA and we're all happy, and now we want to know, what are we going to do with that DNA? Okay? So, what to do with the DNA. And what do we do with our DNA? We make proteins. Yay! That's so exciting. Get swole, yes. Okay. So we do this through transcription translation. So there is what's called the central dogma, which you probably have seen, and I don't know why I don't have a slide of it in my notes, but I know what it's like. Okay, so you have the central dogma, and so we have DNA, and we want to get to a protein. The problem is, DNA is located in the nucleus. Proteins are made at the ribosomes. Ribosomes, site of protein synthesis. So they're made at the ribosomes. DNA will not leave that nucleus. Proteins cannot be made anywhere else. So how the heck are we going to get the instructions to the factory? And so we can do that through RNA. So RNA is our like instruction messenger. And so the process of going from DNA to RNA is called transcription, and happens in the nucleus. And then the process of going from RNA to a protein is called translation, and it's going to happen at the ribosome. So, another thing to note is that DNA has exons, I don't think I spelled that right, and introns. And so if this is our DNA strand, maybe here's a piece that's an exon, here's an exon, maybe another exon or something like that. And so when that DNA when it goes through transcription, I said translation, but I wrote transcription. When it goes through transcription and leaves the cell, we can only take with us the exons. So you can use the phrase exons exit the nucleus. So you might have heard the term RNA and mRNA. So mRNA, there's mature and premature. Premature would be the one with the introns still in it. Mature RNA would be the one without introns. Okay? So, again, DNA can only be built from 5 to 3. It's the same pattern for going from DNA to RNA. You probably already heard this, but RNA is read 3 bases at a time. And so you call that a codon. And so you have this, and again, my notes are going to look really messy to you guys, but you have this code, which you probably have this in your notes, and so it will tell you, based on the codon, what protein it's going to code for. Okay? So let's get into the nitty-gritty. So the first step is transcription. Okay, so we're going to start there. I'm going to erase. Transcription. So again, we're in the nucleus. And we're going from DNA to RNA. There is 3 steps to this. Or 3 parts. I guess we're going to write parts. Alright, so there is initiation, elongation, and termination. Wait, maybe there's not termination. Alright, give me a second. Oh, yeah, there's termination. Okay, there's termination. So, in initiation, so let's draw our DNA. Let's use black. So, if this is our DNA, right? We're going to have to do the same thing we did before, where we have to open up a replication bubble. Just a few reminders. We're going from DNA to RNA. So we don't need to do both sides because RNA is single-stranded. And we would have when we did this before, we translated if it was an A on top, we put a T on bottom, or vice versa. And if it was a G on top, we put a C on bottom, and vice versa. But this time, if it's an A on top, we're going to put a U on bottom, but the G's and C's will stay the same because it's RNA. Okay? So we're using one different base, and we're only going to build one side of it. It could be top or bottom, but we're only going to build one side of it. So transcription, so the first step is that transcription factors or proteins are going to bind to this strand of DNA. And so there's a fragment of DNA that has the nucleotides TATA. And so we call this the TATA box. And that these proteins or transcription factors will recognize this sequence and know to bind here. So transcription proteins bind at TATA. So once those transcription factors are binded, and sometimes you see multiple little proteins there, then RNA polymerase knows, hey, this is where I need to bind. So RNA polymerase comes and also binds. And then, of course, it only builds 5' to 3', so let's say this was 5. Again, the new strand, right? So this must be 5'. 5 on the old strand and 3 on the old strand. And so that's initiation. Initiation is just transcription factors find the tau box, RNA polymerase finds the